Well, thank you for coming this late hour. I know everyone must be a little bit hungry. My name is Shlomi Noach, and this is automated schema migration with GitHub Actions, schema, and Ghost. I'm with the GitHub database infrastructure team. I author a bunch of open source projects, Orchestrator, Ghost. We'll talk a little bit about Ghost today. I work with GitHub. I assume I don't need to introduce the company here. In the past year, we shipped a lot of new products and services like actions, packages, security advisories, code navigation, search, notifications, sponsors, mobile, and more. Seeing that our backend is MySQL stores all our company's metadata, all these new developments imply schema migrations, right? New feature, new table, added column. Oh, we need a new query, so we need this new index. Maybe we drop a few tables. Maybe we do an iteration where throughout the process of maturing the product, we create and then drop tables and change the design all the time. I asked earlier by show of hands how many people run schema migration per month, per week, per day. There were a few people who run a schema migration per day on average. We run 2 on average per day. Of course, not every day is the same. Some days we have like 5 or 6 schema migrations. What is a schema migration, right? On the face of it, it looks like, okay, it's just a create table. It's just an alter table. It's just a drop table. But I think it's a lot more than that. And I will ask by quick show of hands, do you find that you have a lot of manual labor before, during, and after a migration? Does this happen to you? Yes, if so. Oh, not so many. OK. So I'd like to break down how I perceive schema migrations to be in a well-controlled, audited, safe, reproducible, debuggable fashion, which is the way that we do it. So the way that I see it, we have developers who design their features and they create the statement, the need, right? I need this table, I need these new columns. Hopefully they will ask their peers to review. Hopefully, before going to production, I don't just decide something myself and push. This can happen with smaller setups, but hopefully we go through some review process. Hopefully, if you have a databases team, DBAs, they will review it as well, because there's some guidelines that they will be concerned with, like we do or do not support foreign keys. Oh, this integer is signed, it should be unsigned, right? The length of a column, this is a duplicate index, stuff like that. And from there, we need to formalize and make sure that the statement we want to generate is correct. I'll talk a little bit about that later. And then decide where to run this. On smaller setups, you have a single MySQL clusters. On larger setups, you have multiple, 10, 20. Wait, this alter table, on which is that alter table users? Wait, we have users in this cluster, in this cluster, in this cluster. Who figures out exactly which one it is? Who says, who's sure that this is indeed the table we're talking about? We need to schedule the migration. If we run multiple migrations a day, then possibly one of our clusters is already busy right now running a long migration. I'm not going to kick another concurrent migration. It's possible for us, but it really slows things down. We really wait until the first migration completes before we do the next one. So there's scheduling here. We run the migration. We audit it, make sure everything's fine, production is fine, is happy. We probably need to report to developers, hey, what's the status? We sometimes have like a multi-day migration because the table is crazy big. We have a couple tables that take 20 days to migrate. That's like a little bit to the extreme, but we do have some substantial amount of tables that takes hours to a couple days to migrate. And we need to be able to tell the people, hey, you know, it's still working, ETA, 12 hours, whatever. At the end, we need to maybe clean up, drop the old table, let people know, notify them, hey, that's complete. Do you want to test it? Do you want to verify? Come back to me, tell me that everything is okay. And then finally, the developers will do deployments, merges, whatever it is they need to do. Does that make sense? Would everyone agree that there's a little more manual toil? Maybe I wasn't very clear previously about what manual labor it is around the migration. So yes, raise your hand now. Yes, okay, good, thank you. Internally at GitHub, we actually happen to, for a long time, to own even some parts of the developers' roles. Because we own so much of the process, we took ownership of this extra step. So for us, this was a real problem, because if we need to run 5-6 migrations per day for some days, we are a human scheduler, multitasker, context switcher. Okay, I need to begin this. While this is running, I'm going to review this. Oh, this is complete. Let me kick the other one. This put a huge amount of toil on us. Best case scenario, hours per week. Worst case scenario is hours manual labor per day. And we sought an automation to solve that. And so what we're going to do now that we've explained the problem space, I'll illustrate the solution we came up with. So before showing the solution, I'd like to tell you that the problem is complex. It's complex not because it's like rocket science, but because there's different environments here, different ownerships, right? The code change comes from a developer, but I'm a DBA running it, and maybe there's an SRE team to monitor, or maybe it's the same team for you, but there's a development environment and then production environment. How do you bring this from here to there? And in a search for a complete solution that knows all the environment, which means it has credentials to all the environments, it can control anything, it's pretty risky, we came up with a design that is a combinatory solution, right? A few loosely coupled applications or solutions, each responsible on their zone or realm, and orchestrated together to bring you a full solution. And this is what I'd like to describe. So the first thing to note is the code. I asked earlier who here don't even review their code. A few people raised their hands. In my opinion, a schema change needs to be part of the code and needs to be reviewed as if it were code. That's my opinion. Specifically at GitHub, it's a necessity. For example, we don't only have GitHub.com, we also ship GitHub Enterprise, an on-prem solution, right, that sits on a customer's place. And while we do continuous deployments to GitHub.com, we do periodic upgrades, like every few months, whatever the time frame is, on a customer's host. And we need to be able to reproduce those schema changes and the code updates that we did on .com on the customer's computers, which means we have to have the log, or we have to have the version. We need to know exactly what migrations we ran, and we need to decide up to where, right? Where am I going to upgrade to? And that should be coupled with the code, because if I put the wrong schema version with the wrong code, everything will explode. And so, in my opinion, schema changes should be treated as code, and internally at GitHub, we always couple the schema changes or the schema design within the same repo of the code that uses them, always together. To that effect, we're kind of beginning to figure out how the solution begins, because if we're going to treat schema changes as code, then for us at GitHub, we happen to have a solution to that. We happen to know a Git hosting service that provides, versioning and then source control and reviews, etc. And that's the very platform that we develop. And so for us, a schema change is coupled with what we feel is the heart of the GitHub flow, which is the pull request. So for us to make a schema change, a developer would check out, branch, modify the schema, commit, push, create a pull request. The pull request is the place where the developer would seek peer review or DBA review, where we would discuss the schema change, say this is good, this is not good, let's move on. This is where CI runs, this is where communication goes. And for us, it looks like this. So in this sample PR, I create a pull request, I describe what it's for. I made a few larger slides. I knew the slides here are not well visible to the people in the back. So the way we run design our schemas or version our schema is that on our file system, we have the declarative approach, the create table statements for our schemas. And when I do a schema change, what I do is I create a PR, and my commit reflects the new schema design. This is smaller, but higher, right? So I added a column, I dropped an index, and this is my new schema design. I don't explain how to get from here to here, but I explain what I want to have with this code version. That's a declarative approach as opposed to the programmatic approach where you version the alter statement itself. So if we use this declarative approach, then how do I know what the statement is? Like, what migration do I need to run? This is the before, this is the after. Git diff is not the good solution here. It's very bad with diff in SQL. And to that effect, we use schema. Schema is a fantastic open source tool by a friend from the community, Evan Elias, who is not here today. He's based in the US. It's open source. I'm going to do injustice because I'm going to really describe it in a couple minutes. It's a tool for automated schema migration control. We use a subset of the capabilities of these tools. And one of the, I'll show you how we use schema. The thing with schema is that for people who use Git or general purpose version control, this will feel very familiar. The idea with schema is that in my repo, in my code, I will have some root path. And then for each database that I have a subdirectory. And for each table, I have the definition file, the SQL, that defines that table. Okay, so far? Cool. There's also some schema configuration files. Schema configuration files tell schema, given an environment, where to find the database server for that environment. Okay? So schema gets access to database servers. If you want to later give it access to production, give it access to production. If it's QA, testing, staging, whatever you choose, you tell schema what's the environment and what are the credentials and location. The table definition files, just the normal create table, nothing interesting about that. Okay, so far? So schema sees a file system with database and table layout on one hand, and on the other hand, it has the information to connect to your databases. And you can do some interesting things with schema. You can say, schema, please push. Schema push will connect to your database and apply whatever schema is defined in your file system, which will apply to the database. It will create tables as needed. It will drop tables as needed. It will alter tables as needed. And the nice thing is that the schema is very good about analyzing the correct diff and generate the correct and well-formed schema alter statements. You can also ask schema to pull. So just overwrite my file system with whatever it is on the database. And finally, which is roughly what we use, you can say, schema, please diff. Don't do anything. Just output the necessary alter statements that would take my database from its current state to the one in the file system. Does that make sense so far? Cool. Where do we run schema? Earlier last year, we released GitHub Actions. GitHub Actions is a place for you to run code, almost arbitrary code, as response to events on your repos. An event could be the creation of an issue. Someone closed an issue. Someone pushed or created a pull request or requested review or reviewed or added a label or whatever. Something happens on your repo. And the code that you would run runs in a container. The container runs on GitHub's own infrastructure. You don't need to provide that container. You don't need to do anything. You just create an action YAML file, and in that YAML file you would put whatever commands you want to run. It could be shell scripts, etc. So GitHub will run that code on GitHub's infrastructure on your behalf, given some action. And the last but not least is that that container, while it's a container and isolated from the world, has access to your repo. It implicitly gets the GitHub API token to interact with your repo. So GitHub Actions are commonly used for CI/CD, or that's a classical use case, and that's how we're running schema. So we run schema to diff the changes upon pull request, and it looks like this. By the way, GitHub Actions is free for public repos. For private repos, there's some free plan, some free amount of minutes, and from there on it's charged. So it looks like this. This is a very simplified YAML file. That's the action definition file. It's of course incomplete. The actual file is much bigger. It says, okay, per pull request, I'm going to do the next three things. One is that I'm going to check out master, or the base ref. I'm going to check out master. Then, and I forgot to say that the container runs Linux, it runs Ubuntu, along with a bunch of useful software, among which is a MySQL server. So next, I'm going to schema push. So I'm going to apply the schema definition as found on master branch onto the container's MySQL database. Okay, so far? And then finally, I'm going to check out the PR's branch or head, and then PR diff. So essentially asking schema, tell me what the statements are needed to take the database from the master version to my PR's version, to my branch's version. 5 minutes, no way. Okay. And it looks like this. It runs, there's a bunch of steps. And eventually it ends up, what we did is that it ends up in adding a pull request comment, zoom in, comment onto your PR saying this is the well-formed alter statement. This is what schema has analyzed your PR to do. Does that make sense so far? Okay, all this thus far, all this story requires one YAML file. You put in your repo, done deal, okay? The migration itself, create table, drop table, relatively simple. For alter table, we use Ghost. Raise your hand if you've heard of Ghost. Cool, we've described it in previous years. I'm not going to repeat. I'm just going to say that for us, Ghost works very well. It does not make impact in production. We don't need to worry about Ghost running. It's well controlled, well behaved, well throttled, and does not hurt our production servers. So we kind of don't care whether Ghost is running or not. It's good and safe for us. And so the glue, the final glue, is ski-free. Ski-free, the name coined by Tom Kruper. Names are hard. It's based on schema and hands-free or whatever, and we go to ski-free. So this is the orchestrating service that connects the dots and makes the entire flow. And we developed we're developing it at GitHub to solve our migration problems. So allow me to just illustrate with you the entire flow, and you'll understand what ski-free does. Okay, so we begin with the developer who creates a pull request. We've seen this. This is the change. We have that YAML file, the action file. It runs. It generates the diff. It adds a magic label, migration schema diff, right? Hopefully, the developer will ask their peers to review and approve. Someone reviewed and approved. Ski-free is a process that is aware of my repos. While it doesn't have access to my code, my Git code itself, it does have access to my to the GitHub API and to my repo through the API. It looks for open pull requests that have schema diff statements with that label and have been approved by a peer. That means it's ready to ship on. How does it ship on? Schema says, well, yeah, the developers have approved. I'm now seeking review from the database infrastructure team because they're the next step. That's the process. For some repos, we have the DB schema reviewers team who are more application aware, but we could have 1 or 2 reviewers, further reviewers needed. So assuming the database infrastructure team approve, schema sees that. It keeps polling the pull request. What's the status? Well, oh, it's been labeled as, you know, a change, and the user approved, and the peer approved, and the database infrastructure team approved. All right. I compute where I need to run this. Okay, this specific schema change is going to run on this and that cluster. And scheduler is kicking in, and it checks and it knows whether a migration is already running, yes or no, and whether I'm good to go. And as it begins to run the migration, it adds a pull request comment. And as it completes running the migration, it adds a pull request comment. The developer knows. They just know, because all they need to do is listen on their notifications. We use an already established mechanism for GitHub notifications. We don't need to reinvent the wheel. We don't need to communicate to the developer because they just know. We're telling them by automation. Finally, maybe the PR has multiple migrations. We will notify the developer. Everything is done. Please go ahead, do your thing. Great. I'm happy to merge and do whatever I want to do. Deploy, do whatever I want to do. Make sense so far? Cool. So this is how it looks like today. We started running this like 3 months ago. For those sitting in the back, the entire list that used to be owned by DBA now is mostly taken by automation. Where developers should own it, they own it. The DBA team now only have one role in that process, and that is to review and approve the PR. Once we review and approve the PR, automation takes it away. We don't need to think about it anymore. The impact for us is down from hours per day or hours per week to minutes per week. That's the time we spend today on migrations. We don't care. We care because we review, but once we approve, take it away. And everyone knows developers have visibility. They also have chat ops. They can proactively check what the status is. But like I said, they get notifications on the PR page. Everything is communicated through the PR page. Better time utilizations. We don't need to wait for a database engineer to be up and awake at their computer to kick off the migration. The migration just kicks off as soon as possible. So developers have been telling us, how shorter the time was, wall clock time from the moment they publish a request until the moment it's done and in production. Okay, so far, Skiffle was developed internally at GitHub and uses internal GitHub resources and services like our service discovery mechanism and our inventory service and ChatOps integrations and internal Golang libraries, which we have. And so it's not really a general purpose solution, and it's something that's very difficult to open source and to just ship to everyone because it relies so much on our internal infrastructure. And yet we hope the community can benefit from this, so we're open sourcing it. So what you'll get within a couple of weeks, I hope, so look out for a GitHub engineering blog post where we will share this. You'll get an incomplete code. You'll get code that doesn't build, doesn't compile. Compile, it will break, but with some hints and suggestions for you. Okay, instead of using a service discovery, why don't you start with a simple configuration file and then work it out. If the community finds this helpful, we're happy. So hopefully within a couple of weeks, we'll release Key-Free as open source. And I'm happy to take questions. Yes, sir?
Can you talk about the scale at which you're deploying these migrations at?
The scale at which we deploy these migrations. We have over 100 production servers in a dozen more production clusters. We are not huge, but we're very busy, right? So we do have a couple clusters that are like maybe a couple terabytes worth of data set. Others are smaller, but almost all of them are extremely busy, right? So an interruption to those clusters is very quickly reflected as a GitHub incident, right? So what's important for us is to keep everything under the radar. If it takes longer to run, that's fine, but most important to keep it under the radar. Does that answer your question?
Yes,
cool. Yes, sir.
How do you take care that only one migration is running at the same cluster? So do you
Right. Yes. Yes. So Skiffrey itself is backed by its own MySQL database, right? And so Skiffrey is stateless, but everything gets written there. And so Skiffrey can easily check whether there's an entry. There's a live check that keeps updating to make sure. And if the migration dies for some reason, eventually that role will be garbage collected, and we will. Yes, sir? How do we handle migrations that update data? We call these transitions, right? These are not schema migrations. These are like, okay, once we created some column, now you want to populate that column based on some other query. This, we call it transition. This has to do with us, but it's not a schema migration. So the developers design the transition. We call this transition, right? The update, the insert, the whatever. And the one thing that we do provide to them is a throttling mechanism, because this might involve like updating 50 million rows. We don't want to do that in once. We have a throttling service called Freno, F-R-E-N-O. It's listed actually in the first slide. And so this is a pushback service. It's a voluntary pushback service. You will ask Freno, hey, am I good to write to that cluster? And Freno will say, yeah, it looks healthy to me, or no, please refrain from writing. If it says okay, you will write like 50, maybe 100 rows and ask again and again and again and again. So that's service. Do I have time for more questions?
One question.
One last question, sir, in the back.
Do you also migrate schemas when data is sharded on multiple?
Yes, good question. Do we also migrate schemas with sharded tables? We do experiment with Vitess. We are in different clusters. We are in different stages of maturity. And so, yes, Skiffrey is shard aware. So one of the things that is internal to GitHub is our Vitess setup. So Skiffrey can talk to Vitess and verify whether this is sharded, and if so, it knows to run, like your single alter statement needs to run on 3 different clusters or 4 different clusters because the cluster is in 3 or 4 shards. And so it will independently alter the table, and part of the Vitess integration is to update the V schema, etc. But yeah, this is basically handled. Okay, thank you very much.